Today I'm going to tell you a story about the father of genetics, Gregor Mendel, and how he persevered and rose above his challenges to found a whole new field of biology. This is a story about finding your particle, your uniqueness, and rising above the small things to have a really big impact. Gregor Mendel was born Johann Mendel in 1822 and grew up on his family's farm in what was then the Austrian Empire and is now the Czech Republic. One of Mendel's favorite tasks on the farm was to help his father tend the orchard. One of the jobs in the orchard was to graft new plants to make new varieties. I don't know if you've ever tried to graft plants before, but it's highly technical work. You have to cut the root of one plant, and then you cut the top of another plant. Then you have to stick them together in just the right way so that you don't kill the new plant. Mendel learned how to do this at an early age and appreciated precision, technique, and attention to detail early on. Mendel enjoyed science, but his family was not rich. He couldn't afford it to be a scientist. To be able to continue his studies in sciences, he was advised to join a monastery. He became a priest, but he didn't really enjoy being a parish priest, so he decided to teach high school. Then, as now, you have to get a teaching certificate to be qualified to teach. And to get that certificate, you have to take a test. Mendel failed his teaching exam. You can imagine that stung. No one likes to fail. No one likes to have their life plans derailed. So the monastery paid for him to go to the University of Vienna to get extra training in physics, chemistry, and biology. You can imagine that he really studied hard and paid a lot of attention to what he was learning. He did not want to fail again. Fast forward a few years to when Mendel was at the Abbey. He decided to look at heredity. At that time, the blending hypothesis was the accepted theory for heredity. It stated that offspring are a blend of traits from their parents. And this made sense to people. If parents have a child, that child doesn't look exactly like either of their parents, but rather they're a blend of traits from both parents. You get your blonde hair from your mom, you get your athletic ability from your dad. And over time, in future generations, the blonde hair might get lost, and so you could lose traits over time. The problem with that theory was that no one had looked at this trait by trait. People looked at an organism as the whole and looked over maybe 1 or 2 generations. And so blonde hair might pop up again after 5 generations, but scientists weren't looking that far out. So that's where things stood when Mendel decided to start his experiments. He decided to look over many generations and look at just one trait at a time. He eventually looked at 2 traits, but the point is he started simple, one thing at a time. So he started planting peas and paid attention to their properties. He looked at things like pea plant height. If you mated 2 tall plants, what did their offspring look like? What did their grandchildren look like? How tall were they? Mendel also decided to look at flower color, seed shape, seed color, flower placement, pea pod shape, and color. The point being that he looked at each of these things one at a time rather than looking at all 7 at once. In all, Mendel planted around 30,000 pea plants. And so let's appreciate that number for a minute. 30,000 pea plants. And it's not just that he planted 30,000 pea plants. He also kept track of the grandparents, the parents, the children, and so on. The bookkeeping alone is amazing. Not only did he have to keep track of the family trees for his pea plants, but he also took detailed notes on those 7 traits. The pea plant height, flower color, seed shape, color, pod shape and color, and flower placement. He had to be extremely organized to keep all of that straight. I don't think I'm as organized as Mendel was or as good of a note taker. But he learned early on in his childhood that precision and attention to detail are important lessons, and he carried those with him. Remember that Mendel had received extra training in physics, chemistry, and biology because he had failed his teaching certification exam. In both physics and chemistry, there are particles that we can't see, and those particles behave in predictable ways that are governed by natural laws. These particles are things like electrons, protons, and neutrons. And even though we can't see them, we can design experiments to test their properties and to learn more about them. At the time, there weren't particles in biology, but Mendel reasoned, chemistry has particles, physics has particles, why not biology? He reasoned that the thing that's getting passed from parent to offspring were particles. Now we know that that thing, the stuff that gets passed from parent to child, is DNA. But remember, this was the mid-1800s. Scientists couldn't even agree that DNA was the heredity information, or even what its structure was, until the mid-1950s. So, at any rate, Mendel thought about his traits, the pea height, flower color. He thought of those things as particles that get passed from parent to offspring. And this was a radically new way of looking at heredity. While he thought about them this way and looked at these traits over multiple generations, he saw that he could start to understand their properties and make predictions about their behavior, just like the particles in physics and chemistry. There are also equations that can be written to describe and predict the behavior of electrons, protons, and neutrons. So Mendel reasoned that there must be equations to describe the behavior of his particles in biology. So he used math to predict how his hereditary particles must act. He presented his landmark results in 1865 and 1866 and was largely ignored. People at the time didn't really understand what he had done. They took one look at his paper, thought it was too mathy, and didn't really try to understand it. Mendel died in 1884, well before genetics was ever a branch of biology, and he was very much underappreciated. It wasn't until 1900 when 3 other scientists, all working independently in 3 different countries, verified Mendel's results. When those scientists searched through the literature, they realized they weren't the first one to make their discoveries about heredity, but rather Mendel had made them 35 years earlier. Mendel's story is one example of an obscure but highly innovative person that rose from humble beginnings and circumstances to be regarded as the father of genetics. I like Mendel's story because it illustrates several important points. First, even the greats fail. Don't be afraid to fail. You can rise above that failure. Second, everything is related. Being interdisciplinary is important. And third, don't listen to the naysayers. Your time will come. Mendel's did. Thank you.